Hi, in this video we will learn what is the derivative of the logarithmic functions. We'll start with the natural logarithmic function and the derivative of that. Then we'll go further and see what is the derivative of logarithmic function with general base. Okay, so the first rule here is that the derivative of the natural logarithmic function ln x is 1 over x. That's simple. Derivative of ln x with respect to x is 1 over x. And if you combine this thing by the chain rule, if you have ln of something, not just x, something, then this will be the derivative of that something over u. So this is the starting point, the derivative of the natural logarithmic functions. Okay, so let us do some examples here. For this I have, a couple of examples. These functions are given, we have to differentiate. Derivative of ln x is 1 over x, derivative of ln of box, anything inside u is derivative of that box over the box. The first one is, well, f prime of x, you differentiate each piece and then add them. And this gives us 1 plus, derivative of ln x is 1 over x. That's the derivative. Here we have quotient rule. Yes, f prime of x is going to be derivative of the numerator times a denominator minus the numerator itself times the derivative of the denominator over 2x plus 1 to the power 2. This gives us what? Derivative of ln x is 1 over x times 2x plus 1 minus ln x. Derivative of 2x plus 1 is just 2 plus 0, which is 2. Let me just write it here. And then the denominator is 2x squared. 2x plus 1 is squared. This one, ft. So f prime of t, this is quotient product rule, yes. So derivative of first one times second one plus the first one times the derivative of the second one. Derivative of t is 1, so we have ln t squared minus t as the first summand. The second one, t times. Okay, so this is not ln of t. We are differentiating with respect to t, but this inside is something else. And you know that the derivative of ln box is box prime over box. Whatever is inside ln, you first find its derivative, then over that box itself. And this gives us ln of 2t squared minus t plus derivative of t squared minus t is 2t minus 1. And in the denominator we have t squared minus t. The whole thing is multiplied by t. This other one, ln of e to the power x plus x. So we are differentiating ln of something. This will be derivative of that something over the something itself. Well, the something here is ex plus x, and we have this. Now, derivative of ex plus x is derivative of ex plus derivative of x, and we have in the denominator this e to the power x plus x. Derivative of the natural exponential function with respect to x is itself plus 1 over e to the power x plus x. That's what we get here. And the last one here, so we are differentiating with respect to x. And well, this is, you see, we have a function to the power 5. So 5 will come out, and then the function, the derivative of function, this is the general power rule, times the function to the power 1 less. This is 5 times 1 plus derivative of ln 2x plus 1. I'll come back and find the derivative of that. And this is x plus ln 2x plus 1 to the power 4. Well, derivative of ln of something is derivative of that something over the same function. And this is ln of 2x plus 1 to the power 4. Well, the last steps here, derivative of 2x plus 1 is 2 over 2x plus 1, x plus ln of 2x plus 1 to the power 4. So these are examples. We'll do more examples, but at this stage we say, okay, we now know what is the derivative of the natural one. How about the general base? So remember the change of base formula. Recall the change of base formula. It says for any base b, log of a base b is equal to ln of a over ln of b. How this is going to help us? Well, when you're differentiating, when you're trying to differentiate log base general b of log of x, then first you can write this as ln of x over ln of b. But ln of b is a constant, so ln of 10, ln of 2, or so on. So you can apply the constant multiple rule, and this will come out, and you will have d dx of ln x. What this says is that if you know the change of base formula for the logarithmic functions, and then you know that how to differentiate ln x, you know how to you will know how to differentiate all the logarithmic functions in general base. This will be 1 over x. There is a ln b in the denominator. Well, that gives us the new rules that we want to study here. So the derivative of log of x base b is 1 over, it's not anymore just 1 over x. It will be 1 over ln of b times x. And if you apply the chain rule here, you will see that derivative of ln u base b is going to be, well, over u ln b is what you will have there, but you have to multiply the whole thing by u prime also. So these are the new two tools that we have here, and with these we are now okay. So let's do some examples. Derivative of x times log x. Remember, if there's no base, it means that the base here is 10. So we have to do it very carefully. Derivative of x times log x is derivative of first one times the second one. Oh, why did I get two O's there? Okay. Log of x plus x derivative of log x. This is 1 times log x plus derivative of log x, the base is 10, won't be 1 over x. You have to multiply it by ln of 10. And as you can see, this will give us log of x plus 1 over ln of 10. This other one, g prime of x, this is log of e to the power x plus 2x. So this is our u here. And then the rule says that find derivative of u over u, but since the log is general base 2, we have to multiply the denominator by ln 2. So this guy is e to the power x minus 2x, and this is e to the power x minus 2x multiplied. Derivative of e to the power x is e to the power x. Derivative of 2x is 2, so the difference rule gives us e to the power x minus 2. Here we have ln 2 times e to the power x minus 2x. And that's the derivative we were looking for. One more, h prime of x is derivative of first one times second one plus the first one itself times the derivative of the second one. Derivative of e to the power x is e to the power x. And derivative of ln of something, base 4, would be the derivative of that something over that something itself, and then multiply it by ln of the base. And that gives us e to the power x log of x squared minus x base 4 plus e to the power x times 2x minus 1 over ln of 4 times x squared minus x. Nice. Okay, and this last example, h prime of t. Oh, this is x, not t. Okay, so we want to differentiate this guy, but this is, you can do the quotient rule here, but better way to do it is this. You see this as this guy to the power -1 and then differentiate. Then the power rule, -1 comes up front. You have to find the derivative of this guy and then multiply it by the function to the power 1 less than the original power. Here, this is negative. Derivative of log x base 2. Derivative of ln x is 1 over x, but base 2 means that you have to multiply the denominator by ln 2 plus derivative of e to the power x is e to the power x, and we have log of x base 2 plus e to the power x to the power -2. If you like, you can write this as log x base 2 plus e to the power x to the power 2 in the denominator minus 1 over ln 2x minus e to the power x. So these new differentiation rules, you need to add them to your differentiation box, toolbox, and use them when you need to.